Okay, good morning everyone. Now, as you can see on the screen, what we are having today is calculation of areas of triangles and quadrilateral with given vertices. So such that when the vertices are two-dimensional, like x1, y1 is just two-dimension 1, 2, s2, y is just two-dimension 1, 2. You understand? And then we have an example. The first example says, find the area of triangle with vertices a minus 3, 1, b 1, 5, and c minus 2, 8. Now to solve this problem, you first understand that the formula for finding the area of a triangle is half times base times height, and thereafter you are going to note that we see half times. Now base here now is a collection of the two values given, or the two should I say the two dimension given, or the two coordinates. So that is times absolute value of side AB times absolute value of side BC. Now before you can now move on, you now have to know what kind of triangle are you working with. If it is a theory question, it's very important, but if it is objective, you may not really take cognizance of that. But for theory question, you need to know the kind of triangle you are working with. So how do we know the kind of triangle we are working with? Then we can make use of the formula for slope. I believe you can still remember the formula for slope. Slope formula is m, which goes to y2 minus y1 over s2 minus x1. I believe you can still remember that formula. So let's deal with the first one, length AB. Remember, we are just trying to use this formula to know the kind of triangle we are working with. So length AB. So where's our AB? These are AB, and definitely this is going to be our x1, y1, s2, y2. Now y2 is 5 based on the formula length AB. So y2 is 5. So we are making use of length AB first, 5. Then minus, what is y1? Our y1 is 1. No, AB. So we are picking the values from AB. So our y1 is 1. Then over, now what is going to be our s2? Our s2 is 1. Then minus, what is our x1? Our x1 is minus 3. So from there we have 5 minus 1, that is 4, over 1 minus minus 3, that is also 4, because minus and minus become plus. So 4 divided 4 is what? Is 1. Okay, we have gotten the first slope, or the first gradient. We now move on to the next one, BC. So to get, so I will call this one M1, and then I will call this one M2. So it's still the same formula, y2 minus y1 over s2 minus x1. They're equals to, now we are working with BC now. We are working with BC. This one we work with AB, but let me put it here. We are working with AB for this one. Why this other one we are working with BC? Okay, very important. Okay, so now what is y2 for BC? Now y2 is going to be this now, 8 minus, what is y1? Y1 is going to be 5 over, what is s2? S2 is going to be minus 2. Then minus, what is going to be x1? S1 is going to be 1. So of course we have 8 minus 5 is 3 over minus 2 minus 1 is what? Is minus 3. So 3 divided minus 3 is what? Is minus 1. You can see, what do you notice there? The first value here is 1, and then the second value is minus 1. That means that this minus 1 is the negative reciprocal of 1. Now what reminds you, what actually comes to your mind when you hear such word, that this minus 1 is the negative reciprocal of 1? Now remember, let me quickly show you something. Remember that when we are dealing with a parallel and perpendicular line, we are told that when we have M1, then that M1 is going to be a negative reciprocal of that gradient. So it can be minus 1 over, you can change it to M2, or still the same M1, doesn't mean anything. So the meaning is that if the gradient here is 1, then because we are dealing with perpendicular line, what happens? There is now become negative reciprocal of this one, which is a minus 1 over 1 or minus 1 over m, and that m is the value here, which minus 1 over 1, which will eventually give us what? Minus 1. So you can see something like that appears here. So that means that the negative reciprocal of 1 is minus 1. And what does that tell us? It tells us that those two lines in this triangle, they are perpendicular. So what are the lines that are perpendicular? That means that we can say that length AB is perpendicular to length what? So length BC is perpendicular to length BC. And how do we draw that in a triangle? It's very simple. Now length AB, that means that you can see that B is key, BB is key. So we can just do something like this. Since it's a perpendicular, that is angle 90 degree. So since B is key, so A can come here, and I bring my B here, and then I can take my C to this part. Yes, so AB is perpendicular to what? BC. Based on this, AB is perpendicular, this perpendicular sign to BC. So in that situation, you remember that angle 90 will be formed. Angle 90 will be formed because we talk of perpendicular line. Perpendicular lines are angle 90 degree. Okay, so we have a right angle triangle there. That means that the kind of triangle here we have is a right angled triangle. So in case you are given a question like this in your exam, you should be able to know that the kind of triangle these vertices can be found is right angled triangle. I hope you are communicating such that this A here is minus 3, 1 based on the question, and B here is 1, 5, and then C here is what? Is minus 2, 8. Okay, we can proceed to get the area of this triangle. So how do we do that now? We still remember that we have a formula here, half times length AB times BC. So we have not gotten length AB. What we did initially was that we wanted to know the kind of triangle we are dealing with. So length AB now, how do we find length of a given value? Is going to be square root of S2 is just like you are finding distance, S2 minus S1 all square. Remember that distance also, this is the sign for distance, length, distance, still the same thing, modulo. So then plus y2 minus y1 all square. So such that this one will give us a, so what is S2? What is S2 of length AB? S2 of length AB, that would be 1. I prefer putting it back here. Minus, what is x1? S1 is minus 3. You can see it's here. Minus 3. I will not show you again. I will just pick those values. Then y2 is 5. Minus y1 is 1. All square. So that this one will become square root of 1 minus 3. That will give us 4 all square plus 5 minus 1, the same thing will give us 4 all square. So that this one will now become square root of 4 times 4 is 16 plus 4 times 4 is 16. So this will give us square root of 32. Now, if the square root of 32, what do we now do? We can split it because this is a kind of a sort value in sort form. So we split it. So what are the two numbers, and when you multiply it you have 32, and one of the numbers must be a perfect square. So it's going to be 16 times 2 because 16 is a perfect square. So square root of 16 is 4, then times root 2 will still become root 2. So we are done with length AB. So same thing with length, what is the formula? BC. You can see. So to find length BC, okay, the same thing is applicable. So to find length BC, you still make use of the same formula. Sorry. So still make use of the same formula. So square root of S2 s2 minus s1 all square plus y2 minus y1 excuse me all square equals to square root of what is s2? What is s2? Now our s2 should be remember we are dealing with bc now. Bc, look at it here. So s2 should be minus 2 because this is s2 y2. So you can see from even from the question s2 y2, you see. So s2 is minus 2, then minus what is s1? S1 is s1 is 1 from the question. 1 all square plus what is y2? y2 is 8. y2 is 8. Then minus what is y1? What is y1? 1y is 5. 5. Okay, you can see all square. Yes, so you have to know what you are doing so that you will not go and make any mistake. So minus 2 minus 1, that will give us minus 3 all square plus 8 minus 5, that will give us 3 all square, such that this one will now become square root of minus 3 times minus 3, that is 9, then plus 3 times 3, that is 9. So that will give us square root of 18. Then we split it just like the other one. Square root of, what are the numbers that when you multiply you have 18? That is 9 times 2. Okay, and that will give us what is square root of 9? 3 times root 2 is 3 root 2. Okay, and see what we have now. And so I want you to go through it again so that you will know that it is not really a difficult work. It's just a little bit long. So in that situation, we are through with our length AB. We have been able to get our length AB as 4 root 2, and then we're able to get our length BC as 3 root 2. So we can now make use of the formula by substituting those values. So sorry, I'll have to turn to the other page. So substitute those values. Remember, area of triangle is half times absolute value of length AB, then times absolute value of length AC. So that will give us 1 over 2 times what is length AB? You can see length AB is 4 root 2. 4 root 2 is length AB. 4 root 2 times what of length AC? You can see it's 3 root 2 times 3 root 2. So of course we can now say that we can even say, okay, how do we multiply this one? We multiply the rational number, the one inside that is not inside the root, we multiply it, and so 4 times 3, that is 12, times root 2 times root 2, that is root 4, because square root of 2 times square root of 2 is 2, because square root of 2 times square root of 2 is like square root of 4, and square root of 4 is 2. So we have 2 all over what? All over 2. So this 2 we cancel this 2. So we are left with 12 units square. 12 units square, or you can say 12 square units. So anyone. So that is the answer. So the area of the given triangle with vertices minus 3, 1, b 1, 5 and 6 minus 2, 8 is 12 units square. Now we are now moving on to the second example. Example 2. I call that one example 2. Now the second example says find the vertices, or find the area of triangle. I want to listen. Find the area of triangle with vertices at a 1, 1, 1, 0. Please, I want you to take note of that. and B 3, 0, 2, 3, 0, 2, and C is 0, -1, 1. Okay, you can see this is a triangle with 3 vertices, and it's also a 3-dimensional vector. Why? Because we have x1, y1, z1. You can see, so 3-dimensional, 1, 2, 3. Okay, so to solve this problem is a little bit different from this. So for this kind of problem, we normally make use of what we call cross products. So you have to understand something here. So it's like we are learning 2 topics at the same time. Concept of cross products. So is this concept of cross products we are going to be using in solving this problem. But before then, you still remember that the formula for area of triangle under this concept is a half times base. A base here is standing as a absolute value of length AB, then times absolute value of length AC. So you need to take note of that. Okay. Now the question is, how do we find the length AB, and how do we find the length AC, and how do we multiply together? So that is what we are going to do now. So length AB. Now to find length AB in this concept of 3 dimension, concept of length AB, please, I want you to listen to this very well. Now let's look at it very well. Where is our AB? This is our A and this is our B. We are going to be taking it one by one. So length AB. So we first of all say 3, that is the first number, minus the first number in B. So length AB, we are dealing with length AB. That's why we are using B and A. So 3 minus 1. So what will 3 minus 1 give us? So 3 minus 1 will give us 2. 3 minus 1 will give us 2. Okay. Now, the next thing, the same thing, second value, 0 minus what? Minus 1. That will give us minus 1. You see the way I'm taking it one by one, even though there is no much time. Then is 2 minus 0. So 2 minus 0 will give us a minus 2. 2 minus 0 will give us 2 minus 0 will be 2, because 0 is nothing, so it's going to be 2. So let's close it like that. So we have 2, minus 1, 2. Please, there is no minus here, because 2 minus 0 is like you are saying 2 minus nothing, that is 2. Okay, then length AC. How do we find length AC at this point? This one too is not necessary at this point, because we are not taking the absolute value yet. So we are just taking length AB. Then length AC. How do we get length AC? The same thing. So let's see, where is C? Is 0 minus 1. 0 minus 1 is different from 1 minus 0. If it's 1 minus 0, that will be 1. But if it's 0 minus 1, that will be minus 1. Okay, so 0 minus 1 is minus 1. Then comma. Okay, I'm using AC now. Minus 1 minus 1. You can see here. That is minus 2. Then 1 minus 0. And that is 1. That is 1. Okay, so when we are done with that, so we are done with length AB and length AC. So the next thing, before the absolute value now, because length AB times length AC can be written this way. Can be written as this: length AB times length AC can be written this way. Okay, take note of that. So what we are actually dealing with first is the length of AB and length of AC. Then the next thing we are going to deal with is the multiplication. Look at it. So we are multiplying this and this together. Then after that, we can now take the absolute value. Since this one is still since the whole of this is still the same thing as this, so we need to first of all do length AB times length AC before taking the absolute value. So since we have gotten the 2 now, how do we now multiply? And that is where the concept of cross product comes in. Concept of cross product, because to multiply three-dimensional vectors, we can apply tools. Yes, number one, we can apply what we call the matrix method or the matrix rule, and number two, we can apply what we call the Saros method. For this problem, I would like to apply the Saros method, because Saros method is somehow simpler than the matrix method. I think maybe you have been taught matrix. I will have make use of the matrix method. Even the Saros method is part of matrix method, but Saros method is somehow simpler and direct than the matrix method. So let's look at how it goes. Please, I want you to look at it very well. Now, from AB now, remember what we are dealing with now is all these ones, they are scalar. 2 minus 1, 2, they are scalar. They are like, here we have I. So this is their component, J, K, I, J, K. So that is their component here. So please take note of that. Now that means that the first value we are going to be multiplying is going to fall in form of I, and let's see how we are going to multiply that. Okay, now look at the before the I, so that you not get confused. Before the I, so let's say now look at the middle value first. The middle value here is -1. We have not started our multiplication. I just want to apply that to that method, Saros method. Saros. So -1, and then look at the number that follows, that is 2. Then you now come back to the first one. So I took the first one, the middle value, then coming back to the next value, then going back to the first. Then the next number you are going to write is the first value that is here. It's going to repeat itself. So -1. So we are done with that. Same thing with this one. So what is the middle value? The middle value is -2. Then what is the next number that follows? 1. You can see, you come back to this one, -1. Then you go back to your initial value, which is a -2. So that is how to do it. So we can now start the arrangement. So we are starting from I. So we are starting from I because what we have is IJK. So how do we do this? Please, I want you to look at it. You are going to multiply this. Multiplication of this, you take it away from multiplication of this. So -1 times 1 here is -1. The minus, that minus is constant there. The -2 times 2 is -4. Please, I want you to take note of that. Then the next one is a plus J, because that is the next one. Plus J, I showed you the other time, IJK. So plus J. So move to the next one, same thing. You can see. So 2 times -1 -2. Then -2 times 1, that is 2. So we are through with that. Then we move on to K. So plus K. I hope you are getting it clearly. So plus K. So the same thing is applicable, plus K. So 2 times -2, -4. Then -1 times -1, that is 1. So that one is going to be positive. So from there, we have I -1 minus times minus is +4 plus J. There is need for us to put this sign to show that it's scalar. Plus J -2 -2, that is -4, and plus K -4 -1, that is -5. So eventually we have -1 plus 4, that is 3. So 3 times I, 3I, plus -4 times J, -4J. Okay, and plus K times -5, -5K. Yeah, that settles that. So the next thing is now for us to now find the area of triangle, which says that half times, you can say absolute value of AB times absolute value of AC, or you can even write it this way: absolute value of AB is still the same thing times length AC. Yes, length AC. Please take note of that. Okay, so that will give us I will prefer that if all of us solve for absolute value of AB times AC, so we can do the two together, no problem. 1/2 times. So when we have absolute value of something like this, what we just do is, remember, we have something of this nature. Yes, I hope you still remember that. We have something of that nature. Then what is the first value here? We have 3. So this one will just be 3 square. Then plus, what is the next value you have here? Minus 4 square. Please take note of that. Then plus, what is the next value? Minus 5 square. So that this one will now be 1/2 roots 3 times 3, that is 9. Then plus minus 4 times minus 4, that is 16. Plus minus 5 times minus 5, that is 25. So that will give us 1/2 roots 9 plus 16, 25, plus 25, that is 50. So that will eventually give us 1/2. Then this 50 have to be split into 2. So it will become 25 times 2. It will be split such that one of the value is going to be a perfect square. So here we have 1/2. Then what is root 25? That is 5 root 2. So 1 times 5 is 5/2 root 2 square units. Root 2 square units, or unit square, anyone, square units. Yes, that is all. You can see. Go back to it again. Go back to the example again, and we see that it is very simple to solve. Yes, just understand some key steps there. The first one, the area of the triangle, which is that. Then the second one is how to find each of the length of AB and the length AC. And then the third one is for you to be able to know how to apply Sauer's law in order to multiply both length AB and length AC together. Then the last one is for you to take the length AB times AC. So those are the 4 things that you need. So you can pick any question and you can solve, and then you get the right answer. Notwithstanding, I will drop kind of an assignment for you, maybe 1 or 2 questions that I want you to solve, and then you need to submit so that I will be able to know how far you have understand this topic. Thank you very much. God bless you. I wish you best of luck in your examination.